everyone. Today we're going to continue to learn about the weather. Past few sessions we have learned about temperature and how to take the temperature using a thermometer. We've learned about humidity, we've learned about precipitation, and today we are going to learn one more step in the water cycle. Before we do, I want to do a quick little demo. What I have here is a cup of ice cold water, and all I'm going to do is just leave it right here, and we're going to look and see what happens. Look at this cup. Look at the outside and how wet it is. I'm just gonna run my finger, show you guys. You see the water droplets. What I'm gonna do now is move the cup. And let's take a look and see what we have here. Where did all of this water come from? So did you guys see that? What happened to my cup of water? Looks like it was sweating, right? It had all these water droplets on the outside. How do you think that happened? Did I come and spray water on it while the video was taking place? Do you think there's tiny little holes inside of the glass that made the water seep out? There's a lot of water, and on my table there was like a puddle of water. Where did all of that water come from? Do you have a guess? Take a minute, think about where that water came from. Was it from inside the glass? We'll discuss in a minute. Well, do you have an idea where that water came from? Do you have any clue as to what happened? Well, remember last week's lab. Remember something we talked about? We talked about humidity. We said that there's something in the air right now. Something that I can't see, something that I can't really feel, but I know there is water in my air right now. And that's what causes humidity. How did that water come and make a puddle on my table? How did it make the outside of my glass wet? Well, when that water in the air comes into contact with a cold surface, that cold surface causes that water, the vapor, the gas, to turn into liquid water. Has to do with a temperature change. the warm air is holding the liquid. The warm air, remember, warm air has more space. It can hold liquid. But as soon as you get close to the surface of that glass, it's colder. That glass is making the air around it also colder. As soon as that air comes into contact with cold air and it becomes cold, well, it says, I can't hold that water anymore. Warm air is bigger. Cold air condenses, it becomes smaller, and it has less room, and it causes the water to turn from vapor into liquid. Now let's do an experiment to see if we can see this a little bit better. For this lab, you're going to need a timer, water, some ice cubes, the recording sheet that's attached to the descriptions part of this video. From your enrichment bag, you're going to need a thermometer. You are going to also need a mixing tool. I'm using a popsicle stick. You can use a spoon, a spatula, whatever you have at home. And you're also going to need a container. It can be glass, it can be metal. I'm using a coffee can. Use whatever you have at home. What we're going to do is, using a thermometer, we're going to find the dew point. We're going to look for moisture on the outside of my coffee can and see at what point, at what temperature, is it cold enough for the water in the air that's vapor to turn into liquid water. What is the dew point? What we're going to do is take our water and pour it into your glass cup or your metal can, in my case, about halfway. The next thing you're going to do is place your thermometer, red bulb side, inside your container, and your mixing tool is also going to go inside. Now what we're going to do is we are going to add ice cubes every minute, 1 ice cube per minute, while you are stirring and you are checking the temperature. We are going to check for dew on the outside of our can or glass cup, making sure that you don't accidentally touch and hold the outside, because then that would interfere with the experiment. Meanwhile, while the experiment is going, you are going to record the initial temperature, which is the temperature now before adding any ice cubes. And remember, we're going to measure both in Fahrenheit and Celsius. And the observation, is there dew or is there no dew? If I see dew, I'll write yes. And if not, I will write no. Let's check our initial temperature. The temperature right now reads about 20 degrees Celsius and about 69 degrees Fahrenheit. And I'm going to look, and there is no dew on my can. Now that I have my initial reading ready to go, I'm going to set my timer, and I'm going to add 1 ice cube every minute, and I'm going to be stirring at the same time. So might need the help of an adult. So I have my ice cube ready. Going to start my time. And I'm going to stir. Getting close. I'm gonna get my second ice cube ready. At the 1 minute mark, I'm going to drop it in and record my temperature. My temperature is at 18 degrees and about 64 degrees. And I'm going to look, and I don't see any dew. We are at 2 minutes. I'm going to drop my ice cube in, and I'm going to check the temperature. The temperature has dropped to 16 degrees and 62 degrees Fahrenheit. And I'm going to observe and see still no dew. Okay, we are at 3 minutes. Dropping in my next ice cube, checking my temperature, and it is at 14 degrees, and we are at 58 degrees Fahrenheit. And going to check for dew, and still no dew. We are at 4 minutes. Going to drop in my ice cube, read my temperature, and it is at 12 degrees, and it is about 54 degrees Fahrenheit. And let's check for dew. Still no dew. Five minutes. Let's drop in my next ice cube. And the temperature reads 10 degrees Celsius and 50 degrees Fahrenheit. And oh, something's happening. I see a little mark, but I'm not sure. So I'm going to still write no, but I did feel something on the outside of my can. We are at 6 minutes. I'm going to drop in my ice cube, and my temperature, I'm going to read, it is at 8 degrees and 48 degrees. And I'm going to check for dew. And I'm still not sure. I'm still going to write a no. I'm not 100%. We are at 7 minutes. Drop in my ice cube. Let's check my temperature. It is about 7 degrees, and we are at 46 degrees Fahrenheit. And let's check for dew. Wow. It's there. I feel it. I definitely feel it on my hand. I'm going to write yes this time. Let's just keep going for just another second. Let's bring the can closer and see if you're able to see. Oh, there we go. Can you see it? Well, I'm going to turn my timer off, and we're going to stop adding ice cubes in because I have dew. Let me find a different corner. Maybe on the black you'll be able to see it a little bit better. I'm going to just take my hand and wipe, and you're able to see. Look at all that water. So here is what my chart looks like. Your chart can look similar, and it can look different. It depends on the temperature of your home, whether you were indoors or outdoors. But if we go based on my recordings, we'll see that my dew point temperature happened at 7 minutes when I had 46 degrees Fahrenheit and 7 degrees Celsius, which is what I'm going to record down here. So I left this for just a few extra minutes, and you can too. You can really see the dew now. Really obvious. It is completely wet on the outside. So the water that we see on the outside of this can is called condensation. The water vapor condensed onto the cold surface. Now what I want to ask you is, can you think of other examples? Where else have you seen this? There are times where I'll wake up in the morning and it wasn't raining, no sprinklers, but I'll find my car completely wet. What do you think that's from? That is also condensation. That's dew. Maybe you'll see it on the leaves of a tree outside. Maybe if there's equipment outside, you'll see it's all wet. Why does that happen? And that usually happens when? Happens in the middle of the night, right? Somewhere about 2 a.m., 3 a.m. And what happens at 2 a.m.? It gets really, really cold. As the temperature drops, that air, imagine air is this big and it's holding water inside of it. What happens to the air as it cools? Well, it shrinks. It actually gets smaller. As it cools, it gets smaller and it has less room to hold that water. And that water has to turn into liquid water. Think about other times that you have seen water on a surface and you have no idea where it came from. It wasn't rain, it wasn't the sprinklers, not a hose. Could it have been condensation? These past few labs, we have gone through the water cycle. We've seen evaporation, condensation, and precipitation. All factors in our weather.